Mystery particle. Okay, so the first thing I'm going to do is I'm going to draw a picture of it going straight down the page. Okay. And we know that as it goes down the page, and it's like we don't know, is it positive or negative, right? But here's what we know. We know that if it's going straight down the page, it's going anti-clockwise, right? So there must be a force to the right on it as it goes down the page. So this is our magnetic force. This is our velocity, okay? And then we also know that the magnetic field is into the page, right? So we're in a region where it's magnetic field into the page. This helps me. It really does, actually. Okay. So put your index finger down this page. Put your middle finger into the page. And it looks to me as if my thumb is pointing to the right. And the fact that that works means that that's a positive charge, okay? So the mystery is taken out of this, okay? Now, if we did this whole thing and our thumb was pointing to the left, but the force was to the right, then of course we'd know it was a negative charge. But we know it's a positive charge because the whole right-hand rule thing works without reversing it, okay? So we know it's positive. And now we're solving for the charge. Okay. So let's do that. To do that, we're going to solve. We're going to go QVB equals, that's magnetic force is centripetal force, right? MV squared over R, and let's see, what are we solving for? We're solving for Q, aren't we? So Q is, oops, got to cancel the V. Q is, why did I cancel the M? The M doesn't cancel. Okay. So we've got Q is MV over RB. MV over RB. Cool. All right, we can do this. So what's our mass? Somehow we know the mass, right? Okay, so let's see. It is going to be 6.69 E minus 27. Our velocity is 3.62 E6. R is 7.7 centimeters, so 0.077. And B is 0.982. Okay, I feel like this is like one of those things we can do with a calculator. So 6.69 E minus 27 times 3.62 E6 divided by 0.077 divided by 0.982. I'm getting that it's 3.2028, right? Times 10 to the minus 19th coulombs, right? And that it's positive. I'm sure of that too. You see what I'm doing there? Positive. I believe this, by the way, is an alpha particle. An alpha particle is 2 protons, 2 neutrons. So that's the mass of an alpha particle. Charge is, since it has 2 protons, is 2 elementary charges. Okay, so now what electric field in what direction would make it go straight down the page? And since it's a positive particle, it's easy, right? We need a force to the left to counteract the magnetic force. Even though I drew them unequal lengths, that's equal in magnitude. Okay, so the electric force to the left would be a electric field to the left. And then to figure out what that is, we would just set QVB equal to EQ. So this is magnetic force equals electric force. The Q cancels, and the electric field is VB, right? So it's going to be 3.62 E6 meters per second, and B is 0.982. Wow, that's a 0 from the twilight zone. Okay. 3.62 E6 times 0.982. I'm getting that E is 3554840 newtons per coulomb. So I go, let's see, 1, 2, 3, 4, 5, 6. So 3.55 E6 newtons per coulomb left. All right. You guys have earned yourself a bonus joke. Why'd the chicken cross the Mobius strip? To get to the same side.